to complete his master's in highway and traffic engineering from the University of Moratuwa in 2011. In addition, he obtained an advanced certificate in IT from the University of Colombo School of Computing in 2007, highlighting his interest in technology alongside engineering. He currently serves as Director of the Highway Design Section and Additional Director of Information Systems and Network Management at the Road Development Authority. He is also a senior highway design engineer with broad experience and has contributed as a visiting lecturer at the University of Mortua, University of Sri Jawaharlal, IESL, and Kingston University in the UK. He is a chartered engineer of IESL, a fellow of the Institution of Civil Engineers in UK, a professional member of the British Computer Society, and a fellow member of the Chartered Institution of Highways and Transportation. We're truly fortunate to have him with us today. I now invite Engineer Sunet T. Salvavidana to conduct the session.
Okay, thank you very much for the nice introduction. We'll start our session today. Can you see me? I think so.
Yes.
Yeah, okay. So, before starting, so I think that most of the people who have joined here are from government and state universities, the bachelors, right? Following the bachelor's degree, is it?
Yes.
Yeah, right. So, what do you know about highway design? Right, so this is a kind of a niche area in engineering. I know that in most, even in the most of the universities, be it private sector or the government sector, you don't have enough facilities to learn highway design. The reason is uh, now, of course, with the highway boom in this country a few years back, many people went on to study highway engineering, highway design, and both. The thing is, when it comes to highway design, it's kind of an art, right? So nobody can teach you what is highway design and how you are going to do a design. It's a science as well as an art, right? So when it comes to structural engineering, right? Uh, Somebody might call it an art too, but the thing is, it is mostly straightforward, right? So it's just like, okay, now this is the load and this is the number of bars. Okay, so there is a guideline. Maybe it may be British code or Euro code or whatever, and depending on that guideline, you can quickly design what is relevant. Of course, there are some architectural aspects and things, and of course you can do improvements, and of course you can do new innovations like things there also. But the thing is, now when it comes to highway design, it is a perfect art, right? There are some guidelines. So which radius you have to adapt and which super elevation. So don't worry if you don't understand what is super elevation, I'm going to tell you what, right? So these things, although you have some guidelines, the problem is it's kind of an art. So just how to fit a curve, how do you go to a road and fit a curve, right? So your curve may be different from my one. What's the best solution? So what is best solution to you may not be the best solution to me. So it is kind of an optimization, right? So do you know about optimization? I think in operational research and things, you have learned optimization. Or if you haven't done so far, don't worry. In the next years, we will study optimization, right? Optimization in the sense, it is you are trying to optimize. There is no best solution or there is no perfect solution. Whatever you are going to do, that is just an optimization, right? So when it comes to highway design also, what you are going to do is this kind of thing. You are trying to optimize the design, right? So based on that, I'm going to uh, introduce you to this niche area of highway design, right? But please understand, after this hour, don't think, okay, now I am highway design engineer, I can do the design. No, you can't. it needs long hours of studying plus practical experience to become a highway designer, right? But don't worry, any journey has to start with one first step. If you don't start with one step, you can't complete the journey. That can be 1,000 miles, 2,000 miles, whatever, but still you have to start with one first step. And that is exactly what you are going to do today. So you are going to have uh, looked into the highway design field and how these people are going to design the roads. What are they going to consider? These things we will discuss. And I have shared with you two books authored by me. One is a kind of a theory, okay, that's the total theory about highway design, and the other one is, of course, how you are going to do the design using Civil 3D software. Now, Civil 3D software, it's a one software that you can use for highway design, right? But in Sri Lanka we use Civil 3D, Middle East we use Civil 3D. Now last day somebody called me from Canada, okay, not a Canadian, okay, a Sri Lankan who has migrated to Canada, and she told me uh, here also we are using Civil 3D. So it is better if you can learn Civil 3D. So what I am going to do is I have shared my book with Ashen. So he will share these two books with you after the lecture, and I am going to give you my link for my YouTube channel where there you are having lectures one by one, so you can refer them and study yourself, right? So that is an additional help for you, right? So we'll start with highway design, introduction to highway design. Let me share. Give me a second. Right now, I think you can see my presentation. So now, one thing you have to understand is, you know, now before starting, I have to tell you what is this highway and expressway. There is a confusion, right? What is a highway? What is an expressway? Now highway usually in Sri Lankan terminology, we call highway for a national road. So that may be Colombo Candy Road, Colombo Gold Road, or High Level Road or something. That's a national highway. We call it a highway, right? But not all the small roads. Just think that if you are having a road from the township to your village, that could be a highway or not. National roads, right? National road means arterials. Okay, that link one province to another, or one district to another, like. Okay, so there are many types of roads now. A class and B class roads. These are national roads that have been managed by RDA, and you have provincial council roads, and you have Pradesh Sabha roads. Okay, so using highway, what I am going to mean is these national roads, and then the expressway are these roads where you have restricted access, like Southern Expressway or Outer Circle Highway or Central Expressway, something like that. So that's the difference, right? But don't think this is always going to have a sharp edge like that. This is a highway, this is an expressway. Because expressway itself is a highway. Only thing is it is access restricted. That is why we call Outer Circle Highway, right? But in some countries, now if you consider UK, they use the word national roads and Then motorways are the expressways. Okay, in USA terminology they use highway for everything, right? Highways. That is why they are having the guideline Ashto Green Book. In Ashto Green Book, they are considering everything from national roads to expressways with the same word highway. They don't differentiate between an expressway and a highway, right? But in Sri Lankan terminology, we differentiate. Highway is a normal road, normal national road. Expressway is a access restricted road, right? So what I am going to talk today is about national roads, right? So when you consider road, okay, when you consider road, it is a 3D object. Can we design 3D? Now before computers came into being, we could not design any 3D thing, right? So what we did was, we took two projections, one to the horizontal plane, the other to the vertical plane. Okay, so we design horizontal projection separately, vertical projection separately. Now it is easy, right? After that, once you have completed horizontal and vertical alignment, now what you did was, you put them together to create a 3D object of the road, right? But one thing you have to make sure is, you can't take horizontal alignment separately, vertical alignment separately, and do it as two roads. It is just one, it is just the same road that you are designing. So finally you have to go for harmonization. That means horizontal alignment things have to match with the vertical alignment things. With that understanding, we will discuss what is horizontal alignment and how we are going to design it, right? So what is a horizontal alignment? It is usually defined as series of straights and circular curves. Can you see? Now these green colored ones are straights and these red color ones are curves, right? And what are these blue color ones? They are called spiral curves. Spiral curves means, what is the radius of a straight? Infinity, right? So this, but for a curve, it can be some finite value, say 100 or 250 or something like that. Now we use a spiral curve to smoothly convert this infinite radius into a definite one. Understood? Now at this place, the radius of the spiral curve is infinity, and here it may be 150 if the radius of the curve is 150. So like that here also, this can be 150 here, and when it comes to the straight line, it becomes infinity. So that is for the gradual uh, change of the radius. But these are only necessary for high speed environment like expressways. For national roads, we don't use uh, the spirals. So the tangents may directly be connected where a transition curve could be omitted, right? Now when we are going to do a horizontal design, what are our major consideration? Number one is safety. Profile means a vertical alignment. How you are going to do that vertically. Type of facility. That means the same design standards that you are going to use for national highway, you are not going to use for a rural road. Okay, and the design concept that you are going to use for 4-lane road, you are not going to use for 2-lane roads. Then the design speed, that is the most important one. What is the design speed of Sri Lankan national roads? There are two two design speeds. What are they? One is 50, the other one is 70. 50 is for urban areas and 70 is for rural areas. How do you know what is urban, what is rural? Just to look at the place and see, this is an urban uh, landscape. So this is urban. So I have to go by 50 kmph. And so then you travel and you see paddy fields and things. And okay, this is a rural area. I'll go by 70. No, that is not the way. Now usually the urban areas in this country are gazetted. Okay, and you have to refer the gazette to check what is an rural area and what is an urban area, right? But when you are driving, you don't take the gazette with you. Therefore it is the responsibility of the road agency to put the speed limit. They have to put signboard saying this is the speed here, either whether it is 50 or 70. Geotechnical features. Geotechnical features are like what is the soil type, huh? And what about their when it comes to whether this soil will collapse. Okay, so what about the geotechnical features, like what kind of a soil is that, what is their bearing capacity, and these things you have to consider. Topography, whether it is a mountainous place or it is flat. Right of way cost. Right of way means when you are going to have a road, right of way. What do you mean by right? Right is the ownership, right? Right of way. Right of way means the total width of the road. That is what we call right of way or ROW. Okay. Then the right of way cost. So if the cost is very high, say if you are going to build a road for a rural village, you are not going to go for 4-lane road or 6-lane road. Maybe you are going to go for 2-lane road. Okay, like that. So you have to consider the right of way cost and the construction cost. Even though your design is the best one, if the construction cost is very high, you are not going to use that. So you have to find another trace. So then we have to go into curve design, right? Curve design. You know, I will tell you this one because it's very important, right? You have to consider the, now these are some theory stuff, right? So maybe in the university you might have studied movement of a vehicle along a circular path, right? When you are traveling along a curve, what will happen? Now you understand that there is an outward force that is called centrifugal force. If you don't understand this, you just think in your childhood, okay, when the technology has not taken over, those days, I don't know, maybe based on your age, at that time also, the technology might have taken up. But in our childhood, we didn't have the internet or whatever, so we had our own games. One game was taking a ball and you tie a string around it, okay, and you take the string from the other end and then you rotate it around your head. Now, once you rotate this ball around your head, what happens? Ball is trying to come into you or go away. The ball is trying to go away. That is just because of the centrifugal force. Then why doesn't ball go away? Because there is a string and there is a tension. So there is an equilibrium of forces. Okay, therefore the ball does not fly away. In the same way, when a vehicle is traveling in a curve, there is a centrifugal force acting on the vehicle, right? So I don't know whether you will believe this or not, but this force is very high that it can drag away the vehicle. What is the centrifugal force? Usually mv squared over r, right? Mv squared over r. M is mass, v is design speed, r is the radius. Right. Now what we do is we are going to slant this road surface, and with this slanting what happens is component of the gravity comes to resist the centrifugal force. Earlier if it was flattened, only the friction has to resist the centrifugal force. Once you slant the road, what happens is a component of the gravity is coming to resist the what? The centrifugal force. That is why we super elevate it. It is called a super elevation. Okay. So what are the factors? Now with that one, we can actually you can prove this equation. R is radius, V is speed, E is the super elevation as a percentage or something, and F is the friction factor. What is friction factor? F equals mu r, mu is the friction factor. Here we use it as F. So with this equation, of course, you can prove this using general physics. In my book, I have proven this. Okay, so with this one, you know what should be the minimum radius that has to be provided for a given speed and for a given super elevation. Friction is usually same, right? Friction can change depending on the speed, but for a given speed, friction factor is same. Therefore, you can find the radius. So now you know how to get the radius for a particular design speed based on the super elevation. Super elevation usually we give it like 2.5%, 3%, 4%, 5%, 6% like that. So what you have to do is, if somebody asks you, okay, this is my design speed, say 50 kmph, this is my allowable super elevation, say 3%. Now what should be the minimum radius I have to provide? That's an exam sum if you are following highway design. Okay, so you can find it here using this equation, right? So the side friction factor is, F equals mu r. Mu is the side friction factor. So that depends on vehicle speed, type and conditions of the road surface, and type and condition of the tires. So once I say type and condition of the tires, you might wonder, then how do we find the friction factors? Because tires are different from one vehicle to another. But the thing is, usually there are some standard for tires to, yeah. Now now when it comes to tires, there are some particular standards, right? Okay, so for these particular standards, with these particular standards, with research we can find what should be the friction factor. So these are the friction factors that we have calculated using those equations. Okay, and then we will go into the types of curves that we are going to use in highways. There are few: simple circular curves, compound curves, reverse curves, similar curves, and transition curves. Right? So, what are the general considerations of horizontal alignment? Alignment should be maintained as directional as feasible. What is this one? Just think that you are supposed to just think that it is time 1815, right? Just the time that British conquered us. Now they ask you, okay, you build a road to Kandy from Colombo. Now how do you do? You start from Colombo, you go to Galle, and then come to Ratnapura, then go to say Ampara, uh, then come back to Polonnaru, and then come back to Kandy. Is it the way? No, you should try to have a road from Colombo to Kandy in a directional way. That means always you have to keep in mind that I am going to this direction. Anyway, you can have some curves and you can sometimes you will have to come back and go. That is true, but still it should be direction. Then you have to consider the topography. Okay, if there is a big mountain, what are you going to do? You go and cut it down. If there is another way to go, don't do that, right? Or else what you do is you go and put a tunnel. Now in Ruanpura Expressway, we are going to have a tunnel. Earlier we tried to cut the mountain, but the geologists from University of Peradeniya, they came and they did some research, and they said, no, you can't cut the mountains. Okay, so that means they are very fragile. If you are going to cut it, there will be earth slips. Then we proposed a tunnel. But why did we propose the tunnel? Because it was an expressway, right? So you can't go just like in a zigzag manner. So you have to be very much directional. Therefore, we proposed a tunnel. That's after Ingiri, right? So I don't know when they will build it. Then the alignment should generally conform to the natural contours. Natural contours, if you are going to cut the contours, what will happen? That you are either rising or falling. That is not very proper. So you have to keep the number of curves to minimum. Okay. So that means although you know how to design curves, don't go and put curves everywhere. Curves you have to use only when it is necessary. The sudden turns. Have you seen that? Seen those hairpin bends, especially if you go to this Mahiyangani road. Okay, Mahiyangani road. 18 bend road from Kandy to Mahiyangana. There you are having these sudden turns or the hairpin bends. So I was also involved in the design of that at in somewhere in year 2010, right? It was not me who designed it, but the consultant they asked my help to design the super elevation there, right? So how to do the super elevation, because there is no theory for that, so you have to do it in a practical manner. So this they should be avoided as much as possible. So then curve at the end of a long tangent, so that means there is a straight, and then don't put a very small curve. Okay, so you have to provide radii as large as possible, and minimum radii they have to be restricted only for the critical locations. Okay, okay, reverse one I will tell you later. And when it comes to simple circular curves, they have to be minimum radius of curve for superelevation development requirement. What is the superelevation development? Now if you consider a normal road, your superelevation is minus 2.5. That is why they are slanted down. Minus 2.5. In a normal road, it is minus 2.5. Just think somewhere you are going to use the superelevation 3% in one curve. Then, can you abruptly change minus 2.5 into 3%? Then there will be step on the road. So you have to gradually change the superelevation from minus 2.5 to 3%. For that, you need some particular length, usually 30 meters, 45 meters, or 60 meters, something like that. So you have to consider that one when you are going to design a curve, right? Then design speed of the curve should represent the speed below which most drivers operate. What does that mean? So you go and design a road, say for 30 kmph, but many drivers they wish to drive there at 50 kmph. What about your design? It's a poor design. So this happened to us when we designed Hatton Nureli Road. So this road was designed by me and one consultant. Those days before improvement, the design speed was 30, right? So we had a massive investment and we developed it. After that, what was the design speed? Still 30. Why? Even though we widened the road, the curve radii, so we could not improve the curve radii because it is heavily costly. Then again we had to go and put that 30 kmph signboard. Then the people were worried, even our RD people were worried, my God, after this much of an investment, we haven't improved anything. But it is not only the design speed that has to be improved. So there is something called side distance. How how many meters you are going to see ahead of you. That is necessary for you to stop when there comes I mean, not an accident, say just some obstacle is there on the road. So you should see ahead to stop it, and you should see ahead to to overtake a vehicle, like that. These things that you have to think. Now with these things here, depending on the super elevation and depending on the design speed, these are the radii in meters that you have to employ, that you can do. Now if you want, you can use that r equals e squared over 127 into e plus f and then calculate, or else you can easily use this equation, so this table. So adverse crossfall means, what do you mean by adverse crossfall? What is this centrifugal force? That is mv squared over r. When r increases, what will happen? Centrifugal force is going to be less and less. When r is 100, it's going to be less. When r is 1000, it is going to be less. When r is 10,000, it's going to be negligible. So once it is being negligible, friction itself can resist the centrifugal force. So in those places, we call it adverse crossfall. There we don't super elevate. Instead, we put that crossfall as minus 2.5. Right? The transition curves I discussed, that is the radius. It goes from some particular value to, so particular value in the sense here it is infinity, and to a particular value. and here from particular value to infinity, like that. Okay, so I'm not going to read all these things, huh? So but I will just tell you why we are going to put the transition curves. I think most of you have got your license. It is not like our days. In our days, most of the people got the driving license after passing out from the university. Okay, but these days things are different, so you have facilities, so most of you may be driving the vehicles. So when you are driving a vehicle, when you are taking a turn, or when you are in a bend, we call it curve in engineering. In general we call it a bend. So do you go and suddenly take that turn? No. Even though you don't know, unintentionally you are taking a kind of some spiral path to enter into the curve, and that you are doing it within the width of the lane. Okay, but when the speeds are high and the curves are narrow, you will not be able to do this within the width of the lane. In that case, what will happen is you are going to occupy the opposing lane. To avoid that kind of things, we are going to provide transition curves. Okay, then compound curves. Compound curves are, two curves in the same direction with different radii. But why are we going to do this? Why we cannot connect PC and PT with one curve? We can, but if we do that, then maybe it will come like this. It will not go through this PCC point. So then you will ask me, why is it necessary to go through PCC point? If there is no such requirement, of course you can have one curve. But if there is a requirement like that, then you may wonder why there is a requirement like that. Just think, in that PCC point there is a bridge. Can you demolish a bridge and then design another thing? No, you can't. One thing is, it is very costly to do that. Other thing is, we don't go on from, say, for every road improvement, we don't go on demolishing the bridges. So if there is a point that definitely you have to go through it, then you can use compound curves. Then reverse curves are the curves that are having different directions, opposite directions, like this. Okay, here, there, this is a super elevation development. Here you just think this is the LHS side, this is super elevation that is coming. Now what will happen? Here this is the common point of, say, clockwise direction curve and the anti-clockwise direction curve. Now what happens is the super elevation comes down here at the common tangent point, it becomes 0 and then goes down. Here the RHS side, it is coming like minus, and then it increases, and in the common tangent point it becomes 0 and then rises. Okay, so this kind of super elevation change is happening. Therefore these reverse curves are not very preferable, but if you can't do that, you will have to put it. Okay, here you can see how they are going to be uh, located. The similar curves are two curves, sorry, two curves separated by small tangent. These are also not very preferable, right? Then widening, maybe you will have seen this widening. Widening in the sense, you go and, so what is the lane width? Normal lane width. In Sri Lanka, we usually go for 3.5, but uh, due to the speed and the narrowness of the road, the curve, then if you cannot turn within the lane width, especially not a car. Just think that if it is a heavy vehicle or something, so they are unable to take the turn within the lane width. Then what do they do? This is very much visible in, from Avissavella to Ginigathena. In this road, this is very much visible. Okay, so heavy vehicles are coming. What happens is they are going to occupy the other lane, opposing lane. To avoid that, we provide some additional widening. That is what we call widening of carriage on curves. This is there in, Balangoda to Haputale also. You can see these things. Right, so that is the end of my first part. So we'll go to second part. So I think you can see my screen. Now I told you there are two parts. What are they?
Yeah.
Yeah, you can't see.
Yes, yes.
No, sir. It's not visible.
Yeah, sure. I'll share. Give me a second. Now is it visible?
Yeah, now we
Yeah.
can see.
Right. Okay. Thank you. Right. Now I told you before coming here, there are two projections. Okay. One is the horizontal alignment. The other one is the vertical alignment. Now we know something about the horizontal alignment. Now the vertical alignment is here. This is how we design a road. Okay, okay. So that means you have to have two states, and these two states we have to connect by a curve. In the horizontal curve, it is a circular curve, and in the vertical curve, it is a parabolic curve. Okay. So usually the longitudinal profile of a road consists of straight gradients and vertical curves. Okay. Right. Now here there are two types. Can you see here? This is we called a crest curve. Just as English word, right? Crest curve. This one we call the sack curve. Okay. So what are the general considerations? The following general controls for vertical alignment should be kept in view in designing the vertical profile of a road. Right? The selected grade line shall be smooth with gradual changes. That means you should not go and have some abrupt slopes. Huh? You should not have some steep slopes. So they should be consistent to class of the road and terrain type. Two vertical curves in the same direction separated by short section of tangent grade should be generally avoided. Now usually we call them roller coaster. Have you seen roller coasters? I don't know. In Sri Lanka, we don't have many roller coasters. Maybe in Leisure World, you have one. I don't know any other place. But if you go to say Singapore or Korea, then of course they have very nice roller coasters. Roller coasters means you come down, there is a zack, then you go up, there is a crest, and then we again go down. There is another sack like that. So that is better for a roller coaster. Why? We are going to a roller coaster to get some thrilling adventure. Now, do we travel on the road to do that? To get a thrilling adventure? No. Therefore, we should not design roads like that. Right? Then usually on long grades, it may be preferable to place the steepest grade at the bottom. So that means you start with, so the maximum grade usually in a national road is 6%, right? So you start with 6%, right? Then you try to reduce it to 5%, 4%, 3%. At the top, it should be flat. Okay, but don't do it this way. Starting from 1%, then go to 2%, then go to 3%, then go to no. That is not going to work. That is not very good, right? Because we have to consider about the braking distance and all these things. They are here. Hidden type of profile. Now, can you see this one? Hidden type. When you are going this way, you don't see this profile. So these are bad designs. Okay. In connecting roadway and here, this is not a very good design. You know why? Maybe this is the only way that they could do that. But this is not a very good design. There is a crest here in the vertical alignment. In the same way, you are having a horizontal curve also. Horizontal curve and vertical curve should not be put in the same place. Okay, that is not a very good design. So this is the vertical curve equation. Y equals A over 200 LV x squared. So A is the difference of gradients. If one gradient is 3% and the other gradient is 4%, it is 3 minus 4 and the modulus of it. And L is the curve length. So this is the parabolic curve. So there are two types. These are crest vertical curves, right? This type of the curves are called crest vertical curves or summit curves. These are convex, right? Then how we are going to design a crest curve? There are few criteria: side distance, appearance, comfort, drainage, allowable grade change without a vertical curve. So we discuss them. Side distance means when you are going this way, you know there should be like there is a line of sight. If you are going to flatten this line of sight is going to be very high. If you are going to make it narrow like this, then what will happen? This line of sight is going to be less. Okay, so there are some particular values that you have to keep when you are going to design it, right? These are some equations I am not going to discuss, but of course there are some k values. K value is LV over A. LV is, now here, do you remember the K? Here, K value is LV over A. LV is the length, A is the gradient difference. So these are the K values that they have given. So if your design speed is 50, if you have to give stop inside distance, it should be 9.8, right? So these things, I will just give you what is stop inside distance, continuation side distance, and overtaking side distance. Stop inside distance is if you are traveling on a road, if you see an obstacle, there should be some particular length for you to stop it safely without going and hitting that object. And that stop inside distance should be maintained throughout the road. Otherwise, it's a very risky road. Then the overtaking side distance is just think that there is one crawling vehicle is going in front of you and you are trying to overtake, occupy in the opposite lane. These are only for the two lane roads, right? If it is the road is segregated, road is separated, then you need not have overtaking side distance. Now the overtaking side distance is okay. You are trolling behind the slow moving vehicle. Then you take your vehicle into the opposite lane. Then you accelerate it up to the design speed, right? And then you come back to the left lane. For that you want the side distance of some length. That is called the overtaking side distance. If you are continuation side distance means just think by hook or crook now you are in the opposite lane. After that, how many meters you want to continue your maneuver, right? Then that is called the continuation side distance. So if you are going to provide these three side distances, these are the k values you have to give. Okay. Then appearance is the vertical curve has little influence other than the appearance of the profile at very small changes of grade. Say if it is 3.1 gradient and 3.2 gradient, then you have to have that is a very small gradient difference. Then due to the comfort, due to the appearance, we are going to have a curve. These are these values. So then the comfort criterion, so there should be comfort. Okay, so if you are going to have some narrow curves, it is not going to be very comfortable, right? So for that also you are going to have some values. Say if your design speed is 50, you have to have minimum k value 6.5 to ensure the comfort criteria. But you might have remember here you have to provide 9.8 for the side distance. Side distance has to be maintained throughout. Here it says 6.5. So once you provide 9.8, the 6.5 is already satisfied. Then drainage criterion, drainage of course you have to keep it minimum point 0.3 gradient to for drainage. Okay. Then we'll discuss a little bit about sag vertical curves. It is just the same curve but in the other direction. Again, you have to consider now. Do you have to consider the side distance here? No. Why? It is already visible. But you have to consider comfort related vertical acceleration, appearance, drainage, headlight performance, or overhead restriction to the line of sight. What is this headlight performance? We'll discuss. Here, this is because that the sight distance on the sag vertical curve is unrestricted in daylight. But headlight here, depending on the headlight, you have to provide the minimum sight distance. So here also you have to give the minimum values. If it is 50, you have to provide minimum K value of 12. Otherwise, headlight criterion is not going to be satisfied. Then overhead obstruction, have you seen this kind of things? If there is an overhead obstruction, this is the sight distance. Sorry. No, maybe after that. Yeah, here this is the curve length that you have to provide to avoid overhead obstruction criterion. And other criteria, appearance, comfort, and drainage, they are same as the crest vertical curve. Allowable grade change without a vertical curve. What does that mean? So I told you, right? If it is a very small grade change, say 3% one gradient and 3% two gradient, they are going to be connected together, and you are going to provide, say, some curve. Maybe you need not to have a curve if that gradient difference is very small. Then we'll discuss a little bit about grades. Grades are the slopes, okay, gradients that you are having in the road. Okay, there are three types of terrains. One is level terrain. Now, if you are not very much familiar with this terrain, I will just give you an example. Level terrain. I think most of you have gone from Colombo to Kandy, right? So I'll just take the equation. If you want to consider about level terrain, think from Colombo to say Varakapala. It is level terrain, right? And then we have rolling terrain. Okay, rolling terrain means you have mountains and sometimes you have flat roads. Just think if you start from Ambepussa to Kegol, there it is rolling terrain. Sometimes it is gradients, you have gradients, sometimes it is flat. Right, the mountainous terrain, sorry, mountainous terrains, of course, you can think about Kaduganna. Okay, a terrain where heavy vehicles operate at crawl speed. So you might have seen, right? Yeah, these are some standards for grades. So how you are going to provide here? These are the maximum gradients. If it is a class A road, say, okay, Colombo Candy Road, then if it is flat, in flat terrain you have to provide maximum 4%. Rolling it should be maximum 6%. Mountainous it should be maximum 8%. If you are going to provide more than that, your design is substandard. Right, then there is minimum gradients also. Minimum 0.3 you have to provide. Urban areas it is 0.5, and in rural areas it should be zero point 0.3. Then grade is steeper than general maximum. It is something like that. Say that I am telling you, okay, if it is national road, you have to provide 8% gradient. Sometimes maybe you will have to provide 10%. Then there are some distances that you can go with these gradients. Okay. Less important road on a mountainous terrain where maximum gradients are not practical, gradients of 12 to 15 may be satisfactory. Okay, so that is the end of our lecture. But I'll just show you. Okay, I'll just show you a drawing that we have prepared. Give me a second. Oh, first we have to go to Civil 3D and then open. Give me a second, right? Oh, sorry. Yeah, it says that I have to sign in first, so we don't have time. Right. Now that is the end of our lecture. So, do you have any questions to ask?
Good evening, sir.
Yeah.
I'm Tinula from University of Peradeniya.
Yeah.
Uh, I have a question, sir. Can I know whether there is a minimum radius to the horizontal curves in designs, at least in Sri Lankan context, or global standard, or something like that?
Yes, there are minimum curves. Now maybe I will show you. Give me a second. Yeah. Now, can you see this table? I think you can see this table, right?
I think no, we can't.
No.
No.
So maybe again I will have to share. Right now, okay, I think. Now, can you see?
Yes, sir. Yes. Now we can see.
Yeah. And now, just see here. If you consider a design speed 50, if your super elevation is 2.5, 105 is the minimum curve radius you can use, right? If your design speed is 50, if you selected 3% super elevation, minimum curve radius is 100. So if you are asking me what is the minimum radius that can go in the national roads, now usually our national roads are designed for 50 kmph, right? So that may be probably the minimum radius should be say 90 or something like, because even though there are values, we don't go beyond 5 6 like. But in the places where you cannot design for 50, sometimes we have gone for 30 kmph also in some extreme locations. They are usually, as the minimum design radius, we go for 30 meters, 30 design speed, 30, 30 radius. So with 30 radius, we can go with 3% super elevation. Is that the question you asked me?
Yes, sir.
Ah,
Yes.
yeah. Okay, any other questions?
So I'm Hirush from KDU.
Yeah.
So am I audible?
Yeah, yeah, sure.
So are there any specific design guidelines for center medians and sidewalks?
Yeah, for centimeters and
Sidewalks for
sidewalks.
pedestrians.
Pedestrians, yeah.
Yes, sir.
Yes, now of course, when it comes to Sri Lanka, we are using Ostro standards, right? Ostros means Australian road standards. Now, in Australian road standards, they are having a series of books. Okay, Ostro's book series for these centimedians and the race footwork also. There is a particular book. I think it is road furniture or something. But if you just go to this Ostro's book series, you can find it. So there is a book for roundabouts, signal design, and the geometric designs of roads, and for road infrastructure. Sorry, road furniture. That is for the lane marking, and then the pedestrian crossings, and then the center medians, and pedestrian walkways, and all these things. These are available. And other thing is, if you are going to refer Ostro's green book also, all these things are there. But in Sri Lanka, what we do is we don't have such a book. As far as I know, all these are governed by various gazettes. Okay, there is a gazette saying say the lane which should be something like that. So if you are going to provide say a race foot talk, the width of the race foot talk minimum is this, something like that. They are available for centimeter also. They are there.
Thank you, sir.
Yeah.
Sir,
Any
I am from KDU. I
yeah.
have a question about the recent accident that happened in
Yeah.
the place where the accident happened has a small radius to turn the vehicle and a
Yeah.
steep slope on the downward side.
Yeah.
And whatever the speed, the driver had to make a rapid turning movement if he came fast.
Yeah.
And there is only a small safety barrier there. It is not enough. And what do you think, sir? Does some degree of fault lie with the design of the engineer at the design stage?
No, I don't think so. Because in our national roads are usually designed for store standards, right? Now I know this particular place because after this accident, now in RDA we had a big presentation, and these photos were also being shown. Now in that particular occasion, the curve may be narrow because we can't help it. Sometimes in hilly terrain, we'll have to go for very tight radii that we can't help, right? Uh, but in these places, what we do is sometimes we provide some curve widening, and we provide some additional space, like what we call soft shoulder. So there, soft shoulder is also very wide, maybe more than 2 meters like. But now your next question is, the if the driver comes in a very speedy manner, and that is where the problem is. Now if it is a tight curve, usually the design speed has to be 30 to 40. But what happens is, most of our drivers, they do not consider these regulations. They come at 60 kmph, or say even more than that. Then of course they cannot control their vehicle in such a tight curve. So what I think is, we have to raise the awareness, and we have to provide enough signboards saying this is the speed limit here, and we have to raise the awareness saying, now in hilly terrain, if the curves are narrow, of course we have to go in a lesser speed. So what is the rule of thumb rule for this speed, if there is no design speed being displayed, is if you can control your vehicle with that speed, okay, if you feel safe, then that should be the speed. Okay, but if you don't feel safe with the first curve, that means you are going in a speedy manner.
Yes, sir. Thank you, sir.
Okay, any other questions?
Sir,
Yes.
I'm from University of Moratuwa. I have also a question. In Sri Lankan context, most of the roads do not have a separate walking path for pedestrians,
Yes.
and there are actually few roads that have separate bicycle lane. For example, Gol Kalambu Road.
Yeah.
And do you think, sir, it is one of the main reasons for road accidents in Sri Lanka?
Well, now regarding these bicycle lanes, I did a research about the bicycle usability somewhere in year 2014, right? So this research has been cited by many others who are doing research in bicycle lanes. The problem with bicycle lane is, of course, it is very difficult to get our people to ride bicycles. That's one thing. Okay. Why? Because Sri Lanka is a kind of a hot country. It is not like Europe or USA or Australia or whatever, right? So when it is hot, people usually they try to go by a covered vehicle, and the dust and all this and other thing is storage and rains. So there is a problem how we are going to promote bicyclists. That's one thing. But in most of our roads, it is not only the bicycle lane, it is bicycle lane come hard shoulder. Why we have given hard shoulder? If there is no hard shoulder, the drivers don't get a perceived safety. Okay, there is something commonly called curb friction. If there is a curb, they don't think, even though there is enough space, they feel like, okay, I am restricted. Okay, so he cannot entertain the given design speed. But having raised footwork everywhere is not possible. Not even in any country you don't have raised footwork everywhere. Raised footworks are for cities. Okay, in the rural areas we have provided soft shoulder. That means it is not carpeted, but still there is space that people can travel. Well, when it comes to the accidents, in my opinion, I don't see that not providing bicycle lanes is a problem, because there are no bicyclists usually in our country. But providing this race footwalk is a must. Otherwise, what happens is people will come into the road. Now, I have seen in Australia, in Brisbane city, they are uh, race footwalk width is more than 3 meters. Now in countries like ours, it is very difficult. Now even if we are going to have a very wide race food talk, what will happen is the next day somebody will come and then put a boutique to sell something. That's the problem. So the enforcement is also very necessary. And other thing why I see this kind of some accidents happening, there is some illegal parking. Now last day also, when the people from the police headquarters came, I told them, so please go and enforce this law. Otherwise what happens is, when there is parking, what people will do is they will uh, come down to the road and then walk. So these are some reasons for accidents. Yes, you are correct in that case. If in towns, if we haven't provided enough footwalks and things, there can be accidents. But bicycles, there is a question.
Another question I have: when we take a set curve, how we ensure that our car bumper is not collide with the road?
Yeah, that is with the K value. Now, if you are going to provide, the K is LV over A, right? So you have to provide that particular K value. Then your car bumper is not going to hit the road.
Okay, sir. Thank you.
Yeah. Any other questions? Sorry.
Hello?
Hello, yes. Yes, we can hear you. Yes, I think somebody spoke, but now, no. Okay, any other questions that you having?